2 minutes after we have a ways to go. I think we'll say welcome everyone to the caucus. This is our second session on this topic for this particular project that's been funded by the National Science Foundation. And we're so glad you're here to share our results and learn about what we're learning and see what we can do next and what else we can learn together. So what we're going to do today is pretty much spend most of the time reviewing the work that we've been through in the last, not quite a year, but almost a year here in Florida. We started our project as a face-to-face meeting and turned into a questionnaire followed by 2 different caucus events to get through the information that we wanted to collect for this particular project. So today, that's what we're going to do, look at what we've done, talk about aligning and leveling the skills, and what we think we can do next going forward. This was a, let's see, I think, introduce our team. So I'm Marilyn Barger, I'm the Executive Director of FLATE, now part of the Florida Makes Network. And we have Sam Anjani, who's at the College of Central Florida in Ocala, a professor there and co-PI on the project. Dr. Richard Gilbert at the University of South Florida. He's a professor there in chemical and biomedical engineering. And he's also co-PI. And we have Phil Santonzi, was the PI originally when this project was funded, but he's now the Director of Performance Assessment here at Florida Makes. And then my super support and logistics team, June Wolf, who's the Director of Network Engagement, and Tina Berger, who's the Director of Talent Development here at Florida Makes. And last but not least is Maggie, Timms or Times? Maybe Phil can help me there. Timms is our external evaluator. And hopefully she's going to be on the call here today. I haven't seen her yet. And I'm going to turn it over to Richard to review our project and our goals and all that. Richard.
Thank you. Thank you very much. Welcome, everyone. One of the universal issues for any technical efforts is lag. Lag is basically the time it takes for the perception of reality to catch up with reality. And this grant is 100% focused on this issue. It's the lag between the college perception and industry reality. Are the colleges ahead or are the colleges behind this reality? So we have objectives that are focused on creating an activity that will lead us to an answer. But either way, manufacturers still need to lower the lag because we have to improve the connection between the workforce on the floor and the quality of the product. So we just decided to ask both parties what they thought, and we wanted to make sure both of them were in the same room at the same time. The National Science Foundation Advanced Technological Education Program also thought this was a good idea, and they provided some funding for us to execute it. NSF's characteristics are also presented on the slide. It's a partnership between academic institutions. The IHE is higher institutions of higher education for our industry friends, and industry itself. The idea and effort and expectation is to promote education and science and engineering technologies and improve them any way that is feasible. So they support projects with curriculum as a focus, professional development, career pathways, awareness for the students, and technician education research, because it is changing because of Industry 4.0. However, the key thing that is the little line at the bottom. NSF expects that projects will be faculty driven and courses and programs will be altered or developed, but they are going to be credit bearing. The caucus activities turned out to be what has to be done and what's left over relative to this slide and relative to our second effort today. What we've done is we did a pretty extensive investigation of what the world actually thinks of Industry 4.0. We developed some questionnaires or questions for a questionnaire. We distributed that questionnaire. We have collected and analyzed the results. Some of that is the main focus of today's effort with you. We want to share and discuss that with you now as we look forward to what has to be done next. And we've reviewed the caucus and questionnaire calculations and arrangements. So what's left to do? That's down at the bottom in the faded slides. We have to have a report. NSF requires a report, but we have to make sure that we've done this with all of you who have been participating, have had a chance to digest everything that's been going on. So we wanted to do a little brainstorming today as well. We are going to review and define the next steps, and then we're going to do the official dissemination and implementation stages, and the evaluator will send the evaluation package to NSF.
Richard?
And there is another slide, I presume, coming up.
Oh, there it is. Sorry for the delay.
All right, the characteristics of the Future of Work Technicians questionnaires, first of all, required that we get some data. So we have the company or the colleges, the sectors they're interested in, their name, of course, the number of types of employees relative to technician future of work issues, number of graduates they have in our programs. Today's caucus review is really focused on Florida and Florida colleges and industries, and we do know there are other folks who are listening in, and we're quite happy to have their input, but the actual questionnaire was primarily focused in Florida. They were set on skills and selecting them, not necessarily prioritizing them, but selecting at least a subgroup of the number of future technicians hired and the students graduating was of interest. We anticipate that this new technician is going to get hired, so we wanted to know the idea of where they would enter the organization. Would it be entry level or middle or high level? And another issue that's in Florida and probably in the country as well is the impact of industry credentials. So we were interested to know if and which ones industry was focused on. Okay, the next slide can.
Yeah, it's kind of frozen here.
If I presumed I was not the one changing the slides.
No, you are not, but it's not going anywhere. It's kind of frozen. It's frozen up here. Let's see. Do anything about that?
Back up one, please. There it is.
Go.
Thank you very much. The idea of Industry 4.0 technologies is a challenging one. We had to review a variety of sources, and their perspectives were similar. That's probably a good word to use. But we wanted to get as much background information as possible. And we did finally elect to use the Boston Consulting Group's groupings of the technical expectations in Industry 4.0. Our main purpose then now is what is the production technicians' input in these areas. And I think we're going to turn it over to Sam to pick up on that topic.
Yes. So basically, first thing we need to do is define what a technician is. And we pull this in, and you're looking at an individual who has an expertise in that includes a craft or art kind of thing. So in other words, a skill. We're looking at somebody who has a skill, can do things, who can be employed to work on technical equipment and do practical work. And what do they do? So they basically do what you see in the production technician, set up, test, adjust. All these skill sets that you see in here are where everyone, all our technicians, especially coming out of the technical colleges, will have a general or basic entry level skill in each one of these areas. All right, next slide, I guess, if it's.
I'm gonna figure out the best way to, the one thing that makes them go down
Yep.
fastest here. Too many controls.
While we're waiting on that, you can see they
Uh,
also monitor and do adjustments.
Here you go.
So there's a difference in the engineering technology, which is where we're focused on in the colleges, and engineering, say at USF or Florida. And these are some of the differences that we take a look at: a technologist, or actually this will be a technician in the 2-year, technologist in the 4, versus engineering as the formal engineering program. It's planning versus doing, and you look down through these and you're going to see it's more application based versus theoretical and planning. So there's a little bit of theory thrown in with engineering technology, and there's a lot of theory and calculations done there. And the calculations they do, of course, engineering's more calculus based versus algebra based in the 2-year programs. And the 4 years can go up to, if they move forward, into the calculus as well. One thing I do want to key in on is professional engineering registration. Not all states allow engineering technologists, which are the 4-year degrees, to get it. But here in Florida, about a little over a year ago, Governor DeSantis did allow engineering technologists to now become PEs in the state of Florida. They just have to do a couple of more years experience than someone coming out of a formal 4-year engineering program. So the thing on this one here is that these individuals are ready to go out and work on a particular piece of equipment, go. And 2-year program versus a 2-year engineering program, we're getting the skill set and everything you need to go and become a technician. The 2-year in the engineering AA has none of these skill sets unless they've worked in the field. Next slide.
Okay. So we're back to this display of the Industry 4.0 technologies. And I think we're ready for the first poll, Amanda. Amanda here?
Yeah, I think it's up.
Yeah, I launched it. Can you not see it? Okay.
Yeah, so so I forgot to do this one at the very, very beginning because the doorbell was ringing. So we'll do this one now and do poll 2 right after this. Okay. All right. Okay, looks like we're kind of settling in. A few more coming in. Anyone else? 1, 2, 3, 4. There we go. All right, so, oh, few of you have been here. We're here for the first caucus. It wasn't actually open to everyone, so those of you who are from out of state, you wouldn't have even had the opportunity to attend in October, but we're glad you're here now to share and maybe give us some ideas on what you're doing wherever you're from. All right, let's do the next poll. Number 2. There we go. Okay, so this one relates to the Industry 4.0 technologies that you see on the screen. That same list is in the poll, or different answers in the poll. And we'd like you to pick out the 4 that you think are will most impact technicians. This would be entry-level technicians. We consider those to be the graduates of our 2-year technical programs at the state and community colleges in Florida. So just you pick out 4, try to keep it to 4. I couldn't limit you to 4, so let's go ahead and keep putting those answers in. You got the idea, I see. Just give me a couple more minutes. There's a lot to choose from.
In Maryland, you can see the poll
Yes, I can see.
Yes.
them all.
because we have about 30 out of 44 who've responded.
Yeah. Thank you, Tina. All right, so we're going to stop that and look at the results. So the big winner was autonomous robots, simulation, pretty high, additive manufacturing. And what's the next big number here? Industrial Internet of Things. So what we wanted to do, so that's great. So thanks for that feedback. We see some commonality. I'm going to, I don't know if we can go on the slide. Sam, are you ready to go to the next slide? How come it keeps relaunching?
Yeah, I'm ready.
Okay, I'm just trying to get rid of this thing, but it keeps opening back
I
up
just
again.
don't, I just need the
Okay.
next slide up.
Here we go.
Okay, so at this stage, we are looking at.
No,
the
we have to
4
get rid of,
key-
sorry, Sam, we have to get rid of this poll page. At least it's showing up on my screen, so I can't see your slide.
Everyone can
Just click
close
the
it
X.
themselves.
Yeah,
Just
you have
click
to
the
close
X in
it
the upper
yourself.
right.
Yeah, you have to
All right.
close it, Richard, on your
Okay, good,
end.
thank you. Hopefully I was the only one that didn't
Right.
know that.
Okay, all right. All right, so we're going to kind of get a little more specific now. And as you saw, we reviewed it earlier on all the cones that were out there, and you can see them all right here. And the original responses we got off of all these, but which ones really do the technicians need for the future? And, you know, which ones really impact their day-to-day work? So we looked at all these and came up with 4 specific ones that we targeted in this, because we know that in the 2-year technician, they're going to have these sets of skills for sure, or some form of it. Some of the skills are going to be in there, but we're not doing cybersecurity, for example, cloud, because those are more IT programs that work with those. And that's kind of how we came up with these 4. So we focused on these 4 technologies out of the 9. Okay, next slide. There you go. Marilyn, I'm going to turn it back over to you at this stage.
Okay, all right, thanks. So just a quick.
Well, actually, no, actually, yeah, it is for me. Here's some demographics. I'm still on this one. I'm sorry. Yeah, these are the demographics we had here for the number of colleges and manufacturers that actually responded across the state. And as you can see, we got from northwest to southeast, a lot of manufacturers coming in and colleges that applied. Now, what you're going to see in here on this slide is you'll see that from say Jacksonville toward Gainesville over toward Fort Walton. There's some areas and gaps in those areas there. That's because those industries are more geared toward mining and forestry industry. So they're actually doing the timber, chopping the timber down and actually mining the product. And then if you look down South Florida between say Fort Myers and Fort Lauderdale area or West Palm, you'll see there's a big gaps in there. It's not because we didn't poll any of those, but that's more agricultural. It's not really a manufacturing, it's more farming, like US Sugar and such. So those are kind of things that we saw when we did this. And so those are the only reason those gaps are there, but the key manufacturers are on here across the state. So let's go on to the next slide.
Okay, so I'm going to take it now for a few minutes and review the responses we got from the manufacturers and the educators. So there were 2 separate surveys with slightly different questions. We didn't ask about the educators, for example. We didn't ask about their employees. We asked about the number of students that they had in their program and the number of graduates, but we still asked them to respond to the skills question around those 4 Industry 4.0 technologies that Sam just pointed out in the previous slide. We fondly called that picture and those technologies cones. So if you hear that word slip in every once in a while, we thought they looked like ice cream cones. So we often called them the cone technologies. So the difference was just the perspective of the responders. And we asked them very specifically the same question we asked you to pick the 5 top, well, we asked you to pick fewer, but the 5 top technician skills in that same list that would entry-level technicians would be impacted by in the coming years. So now we have a little
Manufacturers have
video.
identified 15 skill areas. Survey information has been acquired from 133 manufacturers and 21 of the 23 colleges that service these manufacturers. This information has been filtered, sorted, and analyzed to identify skill gaps in high demand areas of concern to manufacturers.
Okay, so that was a fast forward little video of kind of the process we went through. It was visual once we got the data out of the Survey Monkey. And what you'll see now with this table is a summary of the responses for the different selections for the different skills. So looking down this table, on the left, you'll see the 4 different technologies in different colors. So the blue was the autonomous robots. That was one of the technologies that Sam pointed out. We thought it would impact the technicians significantly. Simulation was another one of those. The industrial Internet of Things, the third, and additive, subtractive, and advanced materials. We actually added to the additive manufacturing technology cone, not to leave out subtractive and materials, which is very important for both of those technologies, the additive and subtractive fabrication. So that was a little poetic license we added for our industry here in Florida. So we did define a couple of different skill areas under each of those technologies, and that's what you see after the colon of each of these, of every item in this list. So kind of trying to pull out some more specifics beside just autonomous robots, different levels of interacting with technology. And so now you'll see on the right, you'll see the percentages of the educators and manufacturers that selected each of those items. Remember they each picked 5, and we had the 133 manufacturers and 23 educators. So we had all that data, and we had to make some decisions about how we were going to tackle it. And these are the questions that we kind of settled on. Which skills were selected less than 30% by both groups? Which were selected more? Which were selected more often by manufacturers, and also which ones were selected more often by educators? And lastly, which ones showed the biggest gaps between the manufacturers and the educators? And we wanted to kind of hone in on if there were issues with communication. Did they not interpret the questions the same, or the skills the same? So here's where we went from there with those criteria. You'll see the ones that didn't meet the 30% mark, we've grayed out here. And the difference in the two percentages between the two groups is in this last column. We've added that here. The red numbers are the skills that industry selected more than the educators. The black ones are skills that vice versa, that the educators selected more often than the industry partners that responded. So a couple things we honed in on this slide. You could have seen it on the last slide, but the largest difference was 39%. 51% of the manufacturers selected this, and only 12% of the educators. And it was participating in developing existing and new products and operations. So this is a kind of product development. It's probably a skill we associate often with engineering. But it turned out in our coming up, you'll see that we had a lot of expectations of technicians to be part of that process from the manufacturers. So thought that was important. We also kind of honed in on this idea that in the simulation technology area, the industry chose those items over the educators significantly all the time. They really honed in on these simulation ideas and skills. All right, so next, I think we're turning it over to Phil for the caucus discussions.
Yes, thanks. Good morning, everyone. So we're going to take a look at, briefly here, and talk about the skill discussions that we had at the first caucus in October, and show you some of the results that came from that. What you see on this slide are the technology areas and skills, which were responded by both manufacturers and educators, but in each case, they were more, 30% or more had responded, that these were of importance to them. What you see in the fourth column, the delta column, it shows the difference that Marilyn was just talking about on one of the previous slides there. And of course, the red numbering shows where the manufacturers had a higher response rate than did educators, and the black was vice versa, as she said. What we did with this list, and you can see in the fifth column there where it says rank, we grouped some of them together, and then we ranked, what we had left there. Basically, you can see the 1, 2, 3, 4, and we're going to talk a little bit more about this in a few slides here upcoming. You'll see them again. So during that first caucus, what we did was we had a discussion about going through all 14 of those technical areas and skills. We asked 2 questions. We asked, as you can see there on the screen, what is the technician's role, and what skills do technicians need in that role? And we actually had 2 discussions going on about that, so to speak. We had one, which was the audio discussion, where people were actually talking, during that meeting, and bringing up discussion points, bringing up responses to those questions. And we had the bulk of the discussion was in the chat, where we asked for responses to those questions in the chat from the participants in the Zoom room that day. What we did, what we found actually by the end of that discussion, that the responses to both those questions were very, very similar. It was almost as if we just had one question, just asked 2 different ways, and the answers that we got were very similar. So we collapsed basically all the responses into a single set of relevant responses. Again, because they both didn't matter which question was being answered, they really both answered the same, the responses really answered the same question. So we took all that data together. So here what you see is that, each of those ranked groups that I mentioned a few slides back, 1, 2, 3, 4, you can see the number of comment responses that were received from manufacturers and the number that we received from educators. It was quite a large number, as you can tell from what you see there. Again, those are the combined responses, whether they were audio or from the chat, and like I said, the bulk were from the chat box on that day. In the next couple of slides, you're just going to see some examples of the responses. We're not going to take you through all of them. I'm just going to flash a couple of these up on the screen so you can see the answers to question 1 and the answers to question 2. In this case, for the autonomous robots, programming and systems integration, technical skill area. And you can take a couple of seconds to read that. And here's a second. That's all right. This is simulation, performing root cause analysis. You can see the kinds of responses that we were getting from each of those during that discussion. And again, these are the relevant comments. There were some others that were off topic. Well, they were all related to the education, but they really didn't respond to those questions specifically. But so we just brought it down to what was relevant. We also at what you see on this slide now are the 37 essential manufacturing technician skill areas. And what we did from all of the comments that we had, as you saw some of those in the samples on the previous slides, we condensed them down or distilled them down into keywords or key phrases within those comments, so that we could it would be much more it would be more easily handled and more easily understood. And we ended up with this list that you see here, the 1 through 37. The different boxes don't mean anything. It's just trying to get a lot of information on a slide. So anyway, hopefully you'll be able to, you can read some of those as we go up there. So these are all 37 of those that have been distilled out of all the comments that we received during the discussion at the first caucus. Let's just see. And you may actually, this list, just kind of a little side note, for any of you who may be interested in writing job descriptions for technicians, you might be able to draw from this list some of the things that you'll ask for or you're looking for in new hires, to fill technician positions. But anyway, this list may be helpful to you in that as well. What we're going to do next is from this list, we'd like you to simply just take a quick back one slide. Yeah, back one slide. Back one more.
There we go.
We'd like you to take a look. It'll take a few minutes, for you to go over the list, read it, and just enter in the chat if you could. Just pick the number. Don't write down all the words. It'll take too much time. Just write down the numbers of what you think may be the top 3 that you would select from this list for technicians, obviously relevant to your businesses. So go ahead and take a couple minutes to go over that and start. If you could just put that into the chat. Marilyn, I don't think we have any Jeopardy music or anything like that, do we?
I don't think so. Richard will sing for us. We're getting some responses in the, there we go. They come.
Yeah, started to see some responses, and a couple of common ones I've seen so far looks like 627,
21.
7, 21. Yeah.
Troubleshooting. 27, math, communication, teamwork, problem solving.
Critical thinking. data interpretation.
All right, anyone else? Let's see.
A few more still
A
coming
few
in.
more.
There's 15 root cause tools. 37 diagnosing and understanding the full process. Yeah, troubleshooting keeps coming up as well. And many others.
Any others? Yeah, this is great. Thanks for participating in that. We didn't prioritize this list at all. We just tried to distill it from the conversations we had in the chat and verbally at that first caucus back in October. And we just wanted to collect them. And we also thought they were quite all important. And as Phil mentioned, that they could be possibly used for job descriptions. Okay, so I think right
Thank
now we'll go ahead and move on. If you want, you could have taken, these slides will be available, but if you want to keep looking at them, you might want to take a screenshot or a camera shot of the slide and think about them. We'll be revisiting them a couple of times going forward, so they'll still be available. But we will move ahead. I don't know if I can do that. One of the things we did was that, oh, 37 is like a lot. And we decided to try to put them in groups of different, things that went together, skills that went together. And we ended up with, we didn't limit ourselves to these particular categories, but we ended up with 6 after we just put them in groups, and then we assigned these names to them once we looked at the skills that were in these 6 groups. So we called this our rainbow analysis, our color analysis. And we did not limit the skills to one category. If we thought they were important to interpersonal skills and problem solving for quality, we put that particular skill item in both categories. So we just put everything we thought was important together in these particular groups. And here's what fell out of that. So some items, remember, some of these items you'll see in all 6 of these categories, and some you'll see in 1 or 2. Every one of them made it into at least one of the categories. So here's the interpersonal list. Just let you take your eyes down that list and see what kinds of things you'll recognize from the 37 skills list. And then going to the next 2 categories, we'll give you a little bit more time here to look at these. We had 2 categories that were kind of similar or focused around problem solving. We called one dealt with quality, and the second one dealt with kind of maintenance, more machine and equipment focused. So I'll leave this list up for just these lists up for a minute or so here. Again, you'll see some items, in a couple of places. And then 2 more of those groups, so systems integration and prototyping. And now the last list, big data and analytics. Now remember, these items, these skill items and areas were basically distilled from the Caucus data input from last October. And it may or may not, there's a comment already here about for technicians, why big data? That's a good question, and we're going to get to that actually in just a moment. So I'll take it back. Here's that whole list again, just merged together again. No priority, no order, not even alphabetical. It was just a question of how we could best fit them all on the screen, on one screen. Okay, so moving ahead, we did take two strategies for addressing this list, or two analysis ideas that we went down. One was to align them to the Florida Department of Education's curriculum frameworks. For those of you who don't know, these are standards and benchmarks that are set for each CTE program in the state. And so, of course, it would be important to see if those skills were in the frameworks that govern the advanced manufacturing program for Florida at the two-year college level. And then the second tactic we went to was to look at these 5 critical cross-cutting skills that we identified. So I'm going to talk just a minute or two about the cross-cutting skills and turn it back over to Sam for the framework alignment. So we did, going back to our 6 categories, we did end up with 5 skills that showed up in all 6 of these categories. So we were just kind of winging the skills into categories quickly in a kind of fast process. We just identified them and put them in our different rainbow columns as we worked through the 37 and realized that many of them, or some of them, were in all of those categories. And so these are the 5 that showed up in all 5 areas. So we deemed them critical cross-cutting skills that were found for going to be important for any technician, basically in the domain that we were working in here. So I'll just go through those. Technicians' involvement with engineering. If you remember, go back to the skills under simulation. One of them was about technicians helping in new process and new product design and development. So that would be a place where you would see technicians involved with engineering. We thought that was pretty important all across these different areas as well. Critical thinking, I probably don't need to say anything about that as being a cross-cutting skill. Integrating systems, I think this again kind of fits along with critical thinking of putting puzzles together and pieces together, equipment together, or processes together. It's really important skills for technicians and anybody working in advanced manufacturing. Interdisciplinary skills, this may be a blend of, we're not sure exactly what folks meant when they used this word, but I believe integrating all of the fundamentals, maths, communication skills, using all those, integrating different technologies could be considered interdisciplinary. Integrating equipment could be considered some of that, or going between mechanical and electromechanical and electrical. All of those could possibly be interpretations of interdisciplinary skills. And then down at the bottom, diagnostics and understanding the full process. So diagnostics slash troubleshooting, understanding the big picture of what's being produced in a manufacturing facility is really important for technicians, no matter what particular area they might be working in. So back to that, we did deem those 5 important cross-cutting skills for all manufacturing technicians. All right, Sam, I think it's you, and maybe there's a poll coming up with this slide, right?
Right. So
Okay.
this, as Marilyn said, these are the standards and benchmarks in the frameworks that the Florida Department of Education puts together. All engineering technology have an ET core. We all share the same core. It's 6 basic courses. And then these align, a lot of them, well, all of them align up pretty much with the, if some of you know, the Manufacturing Skills Standard Council's certified production technician. It's one of the things that if the student finishes these, they can sit for the exam and pass the 5 different tests to get their CPT. And these are really fundamental hands-on type of skills that all industries in manufacturing kind of have. And then it's broken down into specialization tracks. And there's some standards and benchmarks for those as well. They can be anywhere from, you know, the 18 hours above in the ET core, now go expand out to the 8 to 10 or up to 30 hours in the different specializations. And we focused on, of course, advanced manufacturing, which fits the manufacturing sector. So what we want to do here is just kind of see if any of you have are at all familiar with it. I know I'm hoping all my colleagues in the colleges are, but we were kind of focused more on the manufacturing side. If you have ever either seen these or,
We have a
or
poll,
understand these. Yeah.
Sam, there's a
Yeah.
poll.
And that's what we're heading to next. And so we're going to have you go ahead and do a poll on this one too. So if Amanda, you can throw that one up, I believe you have it set up.
No, no, that's not it. Go to the next poll. No, the next poll, not the next question. Sorry, it's number 4. Was that misnumbered?
Yeah. So if you just take a second and go ahead and answer the question, whether you are familiar or not familiar, and we'll give you a second to about 20 seconds here. So to do that, and then we'll just look at the results here as soon as we get some responses here. Okay, let's see what we get. Oh, there you go. So it looks like a majority of you do have some understanding of that. Out of the yes and no's, I'm hoping yeses, all my colleagues are in the yes. But yeah, so that's pretty good. So it'd be interesting to see manufacturers versus colleges. Kind of interesting.
Okay.
All right, thank you. All right, let's move on to the next slide. So what we're going to do is we're going to kind of break down the
Can't get rid of the thumb poll.
yeah, it's crazy, isn't it?
Yeah.
It's not working right.
That's why we have so many Junes, whatever's.
Right. For some reason.
You got it?
Okay, there we go. Thank you. Thank you.
Okay.
So let's go through each one of these. These are the ET cores that all specializations go through. And as you can see, these are some of the things that we talk about, like drafting, safety, you know, some basic electrical skills, and then maybe some basic troubleshooting. But we do incorporate some of the interpersonal with the communication and math skills, and basically some employability skills in there. Also how business, you know, interaction with business practices and strategies. We talk a lot about that in a lot of the courses we teach. All right. And then I think now we are on the, you should be able to see the advanced manufacturing one specifically that we targeted here. And as you can see, some of the skills that most of you chose, like troubleshooting, you know, and such, are in here. So these are some of the things that we do. So we basically do a lot of hydraulics, pneumatics, and, you know, automation, some quality. And then we also apply a lot of the principles of robotics into this, and then machine interface. So there is a lot of the, I guess, systems integration involved in this as we tie a lot of this stuff together. All right. And what we did with this, and this is just kind of an example, this is not actually the way we did, but what we did was we looked at the frameworks, and then we looked at the 37 skills, and you saw how Marilyn kind of just put them out there. And what we did is we kind of looked and tried to align what works in which particular standard of the frameworks. And when you look here, you'll see a lot of them lined up. And if we didn't have one, so if you're looking at the red block there, it didn't really fit in. What that did was allow us to look at a gap and try to discuss, is there a gap in this, or is this something we need to be teaching? And this is kind of what Richard was talking about moving forward, and kind of where we're looking at is we had to identify what was not in there so we can look at what we want to do. I think the next slide actually kind of shows you the ones we found. And so these were not actually in the manufacturing framework, but there's 4 key ones: the data integrity, data interpretation, the basic understanding of the databases, and the cloud. And so why are these not in there, and should they be in there? And this, I think, is where we're heading into coming up and discussing which skills go with which type of technician you want to go into. So why are these not? Because I don't teach the cloud, and I know in my program, because it's not something that I would expect an entry-level technician to know how to manage. Okay, we can go to the next slide.
Okay, so thanks, Sam. So,
Yep.
you know, it was important for us to take a look at the skills that came out of our analysis from the caucus input that trickled from the results of the questionnaire. So it's trying to keep the process in mind that we've been through. We did identify these 5 skills we wanted to check. When we did the check with the frameworks, they were nowhere to be seen, not even alluding to these particular skills. So we just deemed them as totally missing and needed some investigation or research. And then we also identified some skills that we could kind of assume were part of the frameworks. That's the second list here. We just call them questionable skills that we may need to go back and review the standards and the benchmarks to make sure, or to add some clarity to them. And on further looking at them, we thought maybe they might have to do with, or they do have a lot more to do with how we teach, maybe not necessarily what we teach, and that maybe adding some clarity to that in our frameworks to make sure we provide fundamentals for some of those higher level thinking skills and troubleshooting and critical thinking would need the support of some of these skills in this area. So they are kind of put aside for now. And the next time our framework review comes up, which it's in 2022, in the state of Florida, we review all of the CTE frameworks at every level, every 3 years.
Yeah.
So somebody should go on mute.
Yeah.
Okay.
I'm on a conference, but I'm not
Somebody
speaking
mute,
right
Sam. Oh, there we go. Thanks. Okay, so we did have those 5 gap items we'll return to right now. And you know, our first reaction, of course, probably the reaction of many of the 2-year college instructors and faculty would be, you know, I don't have room to put anything else in my program. And that was certainly one of our reactions as well. So we did decide we needed to really take a look to see if these were really 2-year graduates of the 2-year programs, entry-level technician skills, or were they higher level, maybe, you know, in the post more academic, higher academic degree, or just something they might do on the job. So they are kind of clustered together. This is great merging of IT and OT, of operations and technologies and information technologies, and sorting out who should do what and what skills belong to what technicians is kind of a puzzle for many educators in this area these days. So now I think are we going to another poll on this, Amanda?
Is it that one?
No, it should be the last one here. The one about, that's the second question on that poll.
Yeah, that's it.
Here we go. We got it. Thanks. So within our education institutions, what do you think is the appropriate level for these skills? And you can just answer for them as a group since they're all trending in the same direction. And we'd just like to get your ideas about where you think they fit. And okay, we got some answers coming in. You know, just wing it. We didn't really know when we got to this to these results, so we're really interested to see what others think on the spot. So we have 2-year technician program level, that's the AS degree, or sometime after it. Certainly it's might be in a 4-year bachelor's degree, maybe it's graduate level, nobody's chosen that, and of course, some of us won't know. Okay, should we close the poll here now and share those summary results? So if you thinking it goes in the 2-year technician program, a little more than that after that program, but 41%. A number of you said it goes in the bachelor's degrees, and a couple's not really sure. So thanks for that input. And we can stop sharing those results now.
Can I make a quick comment, Marilyn, with that?
Yes.
You know, the reason
Tammy, would
that
you
I,
introduce yourself?
Tammy Mandel with the University of Florida, UF Biotility. I'm going to add that my decision on my selection was really based on your original description of a technician, of application versus theoretical type work. And it seems like these standards, these skills that you've described are really transitioning more into that theoretical realm. So that I was going to explain, my thought process.
Okay, great, thanks. Thanks for that. Anyone else have a comment on this idea? We're going to move to
Marilyn, this is
yeah.
Art.
Yes.
The hard part for me was trying to answer that question because it's so broad. And I do know for different levels or different positions that I have that I'm trying to go ahead and fulfill would basically be different answers depending on position. So if all of a sudden I have a mechatronics person, or I have a CNC, or I have an advanced manufacturing, carbon fiber, composites, etc., my answer would vary depending on what I chose. So
right.
that's why I could not answer, because I really don't know how to answer it to give you a very direct answer.
Okay, thanks. Art Holke is from Knights Armament in, let's see, I guess Titusville. So he has a big shop over there and actually works with a lot of technicians and does a lot of training and works with a lot of our schools on the East Coast. So I didn't see you come in, Art, so we're glad you're here. That certainly is important. We were just kind of looking for a first pass. These are some new areas, new skill areas, I would say, for a lot of technicians and a lot of different disciplines, not just advanced manufacturing, but I think they're showing up in some others, maybe the energy technicians and nanotechnicians, perhaps, and even the biotechnicians, because we have Tammy on the line with us also. And I just think we are all struggling to see, who is going to be needing these skills and how we're going to, how's best to implement them in the education system so that they're prepared for the work that they're going to have to do.
And Marilyn, my other comment would be for these positions, because between Career Source with Flate, everything else, we're doing all these entry level arenas. I think having a pre-test in order to know the competencies in order to help an employer, an employee, a student basically be able to understand, do they really have the aptitude to go into the field that they're trying to go into? I know with NTMA right now, they basically have a test, and before the company spends a whole bunch of money trying to train somebody, we're able to find out, do they have the aptitude? I know for myself, when I went into the apprenticeship program, first thing I had to do was take a test. And once I completed that test, then they allowed me to enter into a program. Food for thought.
Right, thanks. Some of that sorting probably happens in the traditional college programs as well, in different ways, but certainly aptitude tests are one of the things we all encourage in the colleges. We all have career centers or whatever they might be called, and many students go there to try to figure out what they might want to do with the rest of their life and what kind of program would fit what their direction seems to be, at least at the time when they are getting started. But it certainly is an important point for anyone getting started. So now, again, thanks for that. We're still struggling about that. So we just did our poll, and I'm now going to turn it over to Ron Eglin, who's the chair of engineering and information technology at Daytona State College. Daytona State offers AS and BS degrees in this area. And he was one of our places, one of our sources of information as we were trying to figure out what to do with these skills that we called gaps in the program. And maybe I shouldn't call them gap, because if they don't belong there, then that's then they wouldn't be a gap. Then there wouldn't be a gap. So okay, Ron, I'll change the slides as you call them out here.
Not necessarily. I mean, the gaps themselves. So one of the things that we've been doing, because a lot of the skills that you've been looking at are very difficult to get at an AS level, at that 2-year level. So you're kind of left with a concept of a 4-year degree, or you're left with the concept of doing post-training, both of which work. And we have at Daytona State College, we have the BSET, which is the second 2 years of the degree program. We also run a BSIT, and we also have a number of what we call ATCs, or Advanced Technical Certificates, which pretty much are just collections of courses that we teach within the BSET or BSIT that are targeted towards specific skills versus the broader nature of a full 2-year degree program. Just so you know, our degree programs are not your traditional university programs. You have to have an AS or an AA to get into them. They're 4-year degrees in the sense that they are the +2 of a 2+2 model. You can go forward.
Okay.
Now, one of the things that we kind of look at is some of the skills that you were looking at as far as skills that were not at the AS level are typically taught very heavily underneath an IT degree. So what we see, and I've seen this in places that I've gone to, are a couple of things. One is many organizations obviously have an IT organization within the organization. And the skill sets that go with the people who work in that IT field, just like manufacturing, has many subspecialties that go within it. IT is very, very broad. One of the programs that we do have here is the web system software development. And in that program, the specifics of cloud data and databases are covered, with the specifics of getting into how to be able to actually run and implement, be a DBO, be able to be the software developer that you would have in an organization, or in an organization that is an IT firm, because many firms hire IT firms to run the IT for their firms. So there is a demand and a need for people with those specific skills. SaaS and cloud typically tend to be the same thing. And we do actually teach that here. So you can go forward. Trying to make them quick.
Yeah.
And these are just the courses that go with that specific certificate. And that certificate, we do have people that run through the BSET program that then turn around and do a software. Normally, it's not driven by any personal desire on the part of the students to say, I want to be both a BSET and have this engineering technology background and be able to do software development, other than many times it's, okay, I got to have this skill. I've got this skill. I need this other skill. I need to go back and get it. This is a very in-depth. This is to be able to do client server software applications. This actually web system software development. But we all know that there's a lot of client server applications, especially cloud-based client server applications. We use them all the time. We can go
Ready?
forward.
Okay.
And so that just to understand the concept of a BSIT, I think we all probably have a good idea of what an AS degree has at the inside the manufacturing or the ET side. The BSET, we've got a good idea what that is. But this is what we are one of the few schools that offer a BSIT, and actually an ABET accredited BSIT, which is a BSIS is a different degree. That's Bachelor of Science of Information Systems. That is the IS is a business degree. The IT is a hard degree, and that it's actually all hard skills, primarily focused on hard skills, which is essentially what you see right here. So the IT professionals that are coming out of a BSIT going into an organization in manufacturing would have the expectation of actually knowing these things. Which would be something that would be needed for many manufacturing firms, because we all do a lot of this. Okay. Now, inside the, whoops, go back just one. Inside the BSET.
Go back. I'm trying to go back.
Previous.
There we go.
Okay. Inside the BSET, we only really have one course in programming, which is this course right here, which is called Programming for Engineers. This is a Python course. We use Python, MATLAB or Python. Everybody that teaches this usually uses MATLAB or Python. And it is a course in using computing to solve engineering or engineering technology problems. So it is a problem-solving course. It is not a course in how to write computer programs, from scratch, user interfaces, all that stuff. That is something totally different. What they do in this course is they're presented with engineering problems that they have to turn around and actually use programming. And the problems are designed such that if you don't use programming, well, you're going to be sitting on a calculator for the next 2.5 years. But but writing a computer program, they can be done relatively fast and simple. This is one of the skills we know for a fact now that this specific course is one of the most utilized skills of the BSET graduates, because what they've done is they up their game in their problem solving capabilities by being able to utilize computer programming to do this. Embry-Riddle, it's very much, Embry-Riddle and I coordinate on this course a lot because they're local and I know the people who teach it. They use MATLAB, we use Python, but the concepts are the same. We use Python, it's a free platform, which kind of fits the state college model. But I think if most people have been following computing in engineering problem solving, they now know that MATLAB is pretty much now the dominant force in using computing to solve engineering problems. And that's it.
And that's it. All right, thanks. Thank you very much, Ron. Anyone have any questions for Ron? I haven't been following the chat.
I do have an advantage in that I run an IT program and an ET program. So IT crosses everything. IT crosses medicine, manufacturing, business, and I get to see where all those crosses actually occur.
And that's why we went to you, to find out where these skills are taught and at what level, and what are our technicians, what do they need to know now, but maybe more important, what will they be dealing with in the future? Going back to the technician definition that Sam put up early in this presentation, I personally always think of technicians as the people who keep all the machines running so product can go out the door, and good product can go out the door, and that the quality is met, and that someone else might be doing the other skills, taking care of the IT issues and how exactly things interface with the cloud or at the edge
I
computing?
see a lot from because most of my students actually work in field. So, and I teach the programming for engineers, so I kind of get to see what they're doing. I mean, one of the students that came in that took programming for engineers came in and he came in day one and said, my company has decided that they're going to use Python for programming their PLCs, which is different from using the, the ladder logic based type of programming languages that they would normally do that. In fact, it's completely different how you do that. So they needed to learn that. And, now I'm very curious because I haven't followed up to say, really, how well is this going? How is it working for you? Because
Right.
Python can do almost anything. So, I got that. So,
Okay, we have another question here for you from Mike. Are companies using your program for employee upskilling?
yeah, well, what happens, and the one that they've mostly been using is that programming for engineers, because it has a tremendous amount of flexibility built into the actual curriculum of the course. And a lot of people have been sent back to take that course so that they could learn that problem solving approach. I make the students learn how to use as many external Python libraries as I possibly can, because once they've got the basic programming skills, everything you see in artificial intelligence right now, pretty much everything is implemented in Python, in TensorFlow and Keras. So there's two libraries that just pretty much do all of AI, and they're not terribly hard to use.
Okay, I have a little follow-up question from Mike's question, and that is, so companies send people back to take that course. What positions are those students typically in? Where they come from?
Most of the job titles are something engineer, production engineer, technical engineer, floor engineer. That's the titles that they have. The students typically have, some students do have a 2-year degree. Most of them actually do have a 4-year degree. And the mixture is, it could be a 2-year degree mixed with a BAS or business type of 4-year degree, but they need the technical skills. Or it could be a 2-year degree, AS degree with a BSET built on top of it. So they got and the BSET is very broad. The one thing about the BSET that we have here, that whole thing about product design and being involved in the process of that is like a huge focus of the BSET. There's the getting the basic skills, and then because we're about using them to design. So every student is required to design and manufacture, prototype, evaluate, and test a product. Every single one.
So Ron,
there we go.
Yes.
A small caution, going back to my theme that lag is a universal issue. With Python, that would be a situation where the education system is hugely far ahead of what's going on the manufacturing floor. One of the issues of programmable controllers, which are basically the essential of machine interfacing and operation, is the language choices relative to the ease of the language, but also to the technician's ability on the fly to even have that some technicians have permission to change code to change the situation. Yeah. So although I am not a fan of ladder logic, I would prefer a Siemens approach. There is really not a good idea to add a third-party vendor relative to languages. And I don't mean third-party as a seller, but because the lag of getting the technicians to actually be comfortable with the interface in that language structure does
and actually what you pointed out is we teach our PLC courses with standard ladder logic languages. They don't learn Python to do any PLCs. They use the Allen Bradley and the Siemens. We use the native languages that go with that in those courses. Right. I was very surprised to find out that a student was coming back and taking a course because I don't teach programming PLCs in Python. That is not what I teach. I
Yeah,
teach
right. I
Python for
wasn't
solving engineering problems. But then
right.
the problem that they had to solve was figuring out how to go ahead and utilize. And then of course another question to me was why? Why did the company make this decision to go this route?
Okay,
Right.
we're gonna
I
have
don't know.
appreciate that.
a
I
sidebar
appreciate
about-
that because I know your curriculum quite well, and I would be very interested in their particular why they really took not an orthogonal direction, because all languages could be used anywhere, but it would have been interesting to see if you get access to the student again, if he hasn't gone away. You could probably quiz him and we could get some info about what is it that he's doing different.
Well, I know one thing. The only thing I can tell you from what I've it was not a long conversation, but basic, because we do question them at the end of the class. They are integrating with other systems.
Okay.
Okay.
Thank you.
You can read into that however you want to put it.
Exactly. They must have a particular system, a subsystem that's, precious to them.
Yeah.
Okay.
Well,
all
I can
right,
I can tell you from experience that Python as a glue language is incredible. I mean, you
Yeah.
can find a library to interface anything to anything in Python.
Thank you.
So
Okay, all right, so let's move on from that.
And-
Art, did you have a question?
Yeah, I had just heard something that just as a manufacturer and having 160 CNC machines on site, when I hear Siemens, it is not the only machine out there. Most of my machines are all Mitsubishi, also Fanuc. And so the ladder logic is very critical, not to just pigeonhole into just one arena, but that it covers what the majority of the machines are out there in industry. And Siemens does not cover the majority of equipment in our shops today.
Okay.
yeah,
all right.
we our PLCs that we use in our PLC classes are Allen Bradley and Siemens PLCs, and so the students actually are just using them as. So we only have those two types to teach the classes with. And I think if you go to every school, you might find what the actual equipment used at that school when they teach the PLC courses is usually going to be the same. They're going to be pretty much vertical in their integration of the education that goes with whatever they're using in their labs.
Right. I think it's become in Florida, at least, it's become more and more common for the colleges to have some capability to support both of those two platforms. At least I know there's others still, but both Siemens and Allen Bradley. There's been some acquisitions in the last few years across the state to make sure the students were exposed to a variety, or at least two different PLC platforms, and maybe some of the faculty want to chime in on that. They could do that in the chat. All right.
Very interesting. When we purchase equipment, we're trying to buy a diversity of different types of equipment in the laboratory, so students get exposed to 5 or 6 different kinds of robot. At the same time, when we're dealing with the administration, they're like, buy them all from one company and make them all the same. And that kind of counters the concept of the education aspect of it.
Yeah, that's right. I think we all run into that problem. It has its ups and downs, or its good and bad points of having all the students get the same experience at the same time, or working
Exactly.
with a lot of different machines. Takes a little bit more from the faculty, but it's certainly much more valuable for the students in the long term for their careers.
I think for industry, it's better when we buy it because it is that, buy 7 machines so that you can put 30 students in a laboratory with so many working on each machine at a time is the concept. For me, the concept is have one of everything in there and then rotate the students around. But that's kind of, it's neither, that's our problem, not industry's problem. So we're kind of dominating that, we don't want to go that. If industry says, hey, you need to have exposure to all these kinds of machines, it gives us the ammunition to say, we got to put one of each of these in our laboratories.
That's right. We love that ammunition.
Yes.
Okay. Well, thanks, Ron. I think we'll go ahead and move on. We're kind of coming to the end. We have some few more things to summarize and to think about. So I think, Richard.
Okay, so let's take a quick look at a quick summary. What the project has done, the grant, NSF supported grant has done. We identified some Industry 4.0 technologies in the model that we elected to use. We developed a questionnaire about technician skills. We had the questionnaire and the data and Caucus won responses. We isolated some essential skills. We did some more analysis. We got, jumping down to the last thing, we've got 37 skills with critical cross-skill important areas to technicians. But now we should remember that we are been talking primarily courses and skills, and let's see what we have to do next. What we really want to do is circle back to the Industry 4.0 technologies. And again, we use the Boston Consulting Group's grouping of those technologies. And to circle back, what actually happens is just generated a lot more questions for us to pursue. You know, are the 37 skills new to Industry 4.0 technologies from a technician level? Remember, we are 100% focused on the technician workforce. So it might not be new from an engineering perspective, but is there new level expectations of skills and knowledge at the technician level, the 2-year graduates? And although we haven't emphasized it one way or the other, are these skills fundamental or are they supportive? And if they are supportive, then there's the degrees of support relative to the technology. And then as the technologies advance, education is going to need to keep up. Remember, the lag is usually on the education system side, just because industry is much more focused and targeted on obtaining their product quality and product delivery expectations. So, you know, are there more skills? Are there missing skills? And what are they and how do we do it? So let's take just a couple more minutes to give everybody a chance to tune in or type in on this bottom dot there. What else? You know, you saw the 37 skills. You saw some of the emphasis that seems to be available or of interest in Florida. What do you think about some of the skills relative to their ranking towards the top 5, of course? And are there some that we just blatantly missed? Remember, if Marilyn just goes back one slide, you'll be able to see all of the technologies, even though we didn't pick them, all of them, with the Boston group. Small print there, but you can get the gist. So I will go quiet to see if others want to pop in.
Well, I'd like to hear also some response about, are they, when we think of Industry 4.0, we generally think of really Industry 4.0 technologies and smart factories. We think of really glitzy kind of technologies and really fancy stuff. And yet when we looked at the skill list that we ended up with in our list of 37, I wasn't sure that those skills were in that category. Are they really skills that they are that we are already teaching for the most part? So that was one output there. Or are they new skills? And that's why the question, well, maybe they're fundamental to the new skills that are becoming out in Industry 4.0, that perhaps those particular skills themselves haven't really been defined. So we have
any thoughts and comments there?
We have one comment here from Mike Lasecki. Mike Lasecki is from Arizona. And worked with some manufacturing folks out there over the years, and also had an ATE center more around nano and micro technologies a few years ago. Says he wondered, instead of saying 37 skills fundamental, perhaps we could say, how can we prioritize the 37 if we can't do them all? We could, and this is Justin Camp says we could prioritize the skills based on beginner, intermediate, and advanced, and incorporate that into the education level. So that's a good idea. We could certainly do that. Remember, the one separation or categorizing that we did kind of put them into perhaps different technicians, different specialty areas of manufacturing technicians. Like we had a subset that kind of focused on quality, and another one on maintenance, for example. So we did have some ideas. That's a little different categorization than suggested with the beginner, intermediate, and advanced. Anyone else have a comment about the skills? Are they useful to anyone else?
There was a question that came through the chat area about the big data and the big data characterization and classification. That particular question indicated or suggested that it was one level up, and I'm not arguing one way or the other, but now that we've gone through this a little bit more, maybe we could do a little bit of a focus on the big data, because it's in a different section of the Boston's grouping. So maybe anybody have any thoughts about responding to that earlier chat question about big data? Of course, I have to figure out what big data means, but let's slide with that as we listen to the comments.
Well, remembering we chose just 4 of these areas to focus on for the technicians, and the big data and analytics was not one of them when we put our questionnaire out. However, big data ideas and data analytics, as well as cloud data integrity, that list of 4 things we identified as missing, did come out in the caucus in October. So there was a interesting, another place where we had to kind of deal with that. Obviously, enough people thought it was important enough to include in the caucus discussions, and yet we didn't really tie it to, initially we didn't really tie it to a manufacturing technician job or position or skill set early on. So we just took it and thought we better at least examine what it might, where it might fit, and is it currently a role for the technician? From today, I don't really think that's going to happen, but maybe in the future there'll be more that they have to deal with, the technician does. So we can check some of these comments over here. We got a little more chatter in the chat box. Any of you want to unmute and say your piece? Mike or John, some of these new comments. Dante, Rebecca, want to unmute and
Hi there, Jim Mackey from Unipharma, nutraceutical dietary supplement pharmaceuticals. I'm very impressed that you've got critical thinking in this. I've been working for the last couple of years researching and trying to put together a critical thinking course to avoid silly GMP mistakes, good manufacturing practice mistakes, silly mistakes in a laboratory for quality control, microbiology, chemistry, analytical development. And these mistakes plague the industry, and people are not thinking. It's maybe because there's poor written instructions, maybe because they're preoccupied, but critical thinking. And I'm very happy that you're including critical thinking, because this is, well, critical thinking is critical, but I'm very pleased with that.
okay, great. Thank you. It's just one of those things that's really hard to to teach and have metrics for. So to get some course material together, we'd be interested in that, either working on that with you, or using what you come up with in whatever program you think you're developing. It's certainly something we want to have the students learn and practice. I guess practice is a better word, so it becomes part of their working behavior.
Yes, we've been trying to stress the decision-making process. When you're on your own and you're a new employee, you do not have an experienced employee next to you, your supervisor is not with you, and shame on you if you do not have the standard operating procedure with you. And you have to make a decision. And we stress, well, is your decision going to affect you, the person, you, the peer? Is it going to affect the product, the process, the patient? Are you going to violate a process? So it's almost like the 5 Ps. So it's, that's what we're trying to work on, a very, very basic approach to critical thinking for packaging operators, manufacturing operators that will not have the expertise and the education levels that you guys are promoting.
Mhm.
So I applaud your efforts on that.
Okay, thank you. How about you, Rebecca? You want to unmute yourself?
Yeah, thanks, Marilyn.
Okay.
No, I was just,
Introduce yourself first, please.
Rebecca Short. Some of you remember me as Rebecca Hartley. I just had a name change. But Rebecca Short from the Center for Workforce Development at Clemson, and we also have CAVES as our ATE center. But we work a lot with industry here in South Carolina, particularly the transportation industry. And I know a lot of their technicians, particularly in maintenance fields, are using big data, cloud data, looking at how things over time have evolved and how that changes how they're putting processes in to fix typical or different types of machinery. And so I know that some of the things that were really looked at at the bachelor's level and at the advanced degree level in terms of robotics and autonomous processes, those are obviously very much a part of the technician level now. So I'm careful to say we shouldn't limit what we say we should teach technicians, whether it is at an exposure piece, like a lot of folks have mentioned in the comments, or if we're taking some of those and doing a deeper dive into what's involved in those.
Okay, thank you. Thank you.
One of FLATE's perpetual themes has always been you can't just throw new stuff in response to the comments, these good comments that we just heard. You can't just put new stuff in the curriculum. And that means that some things have to mellow out a little bit or be shifted to a variety of teaching skills. But it also opens up the question to the comments that were just made. If the new technologies, that is the Industry 4.0 technologies, have new skills, then the initial education of future workers there is at the engineering and the upper 4-year college level. And so we are always interested in what part of that curriculum has to be shifted into the 2-year level. And then, repeating myself slightly, if you do that, you can't just add something. You have to be pretty clever about it. So we're always interested in folks with those types of thoughts. And one last thing about the big data, what is happening, because FLATE does get involved with other folks around the country, including Toyota, is we were in the Toyota facility a while back, obviously pre-COVID, but just pre-COVID, and they had big data issues. But the first thing that their floor engineers and their management started talking about was edge computing as opposed to cloud and non-cloud. And this might be a thought for all of us. They've got activities in the cloud and activities outside the cloud, and it's an edge computing effort that is doing this connection. So industry itself is going to stay out of the cloud relative to floor operations. And then as Ron has pointed out today even, there's still the technician that may work in the cloud. And then of course there'll be this third type of person that actually has to work on the edge. So this is an interesting IT proposition that we are exploring as well, because Toyota's no wimpy player, and how they do it is of interest to us. Thank you.
Hey, Marilyn,
Yeah.
just to comment on that, when you're dealing with a manufacturer, I'm also a DoD contractor. So with those questions about cloud, not cloud, and there are many decisions I have to make, and everything I make right now is I have no cloud-based systems on site currently. I know that's going to change as the DoD laxes their requirements, because currently I'm not allowed to, especially for my classified arena of the house.
Right.
So including the NIST 800 and 171, I have my own set of regulations for protecting unclassified information. So it's a big topic, especially in the IT world, on what data can be separated, carved out, protected. So I think it's going to have to be not only industry, but it's going to have to include all the government regulations and requirements that we as contractors are having to face currently. And we need these nice, smart people in the IT arena to help us do that. Data such as ERP systems and everything else, what can be in the cloud, what cannot be in the cloud, drawings, keeping all that separate. And looking at your skill sets, what I look at is, and what I always hope for, is that we have good articulation agreements in place, as well as stackable credentials, depending on which area. So I look at not every one of these is what I'm looking for in an individual as an employee, but possibly 3 or 4 of these, I would like to have those skill sets in a particular individual. And I can elaborate on that, later, but that's what I'm looking at. So for instance, if you do your additive manufacturing, well, along with additive is subtractive manufacturing. Along with that would be my engineering, my finite analysis, those types of things on how to grow that individual to be the professional that I need in that arena. If you go to your robotics, autonomous robots, stuff like that, I look at that is a broad spectrum. So what do I need to have that you have in your industry 4.0, that individual person I want to have multiple areas that makes that individual a well-rounded employee. Personal comment.
Okay, no, great. Thank you, Art. I mean, we need.
I'd like to make one more comment too, just
Yeah,
kind of
sure
off
thing.
that. I think that's a great way to look at it. The other side of the coin too is that how many hats does one technician able to wear and still be effective? So the way I look at it, as an entry level is going to have basic skill sets, and as he goes on to further education and OEM training through the company with their equipment manufacturers and doing more training, this individual gains more skills. Now that individual moves to another level. So moving to that level, they bring on more hats, but then they drop some hats on the bottom because they can't be all. It didn't take one engineer to go to the moon. It took thousands. And so we have to, I think that teamwork we talked about and integrating with the critical thinking skills, like you were just saying, is really the way we have to look at it. And it's going to be based on the size of the company and the number of employees that can support that individual with all these hats they're wearing, and that's where I think we have to take a look at it. So if we're looking at a 2-year technician entry level, what of this does this person need versus a senior level technician who may have had more education, and what skills are they going to use versus one there? So I think I'm going back to what we said earlier, and I believe it was Justin up there saying, we need to categorize them by level. Would probably be a really smart way to do something like that.
Okay, yeah, thanks, Sam, it is important to keep in mind that, we think generically as the technician, like I said a while ago, was that it's the thing that keeps the production going. But at the same time, that our job is, as educators, is to make them, prepare them for that position, to think fast on their feet, to have the critical thinking skills, to be able to troubleshoot and be comfortable with the technology that they're troubleshooting and working with, so production can continue. That's an important piece of what the technician's role is, but also we're the expectation of them to grow in experience, which they get when they're working, and continuing to add on to their own knowledge and skill base and experience bases, preparing them to make sure that they understand that's actually part of their job, is to learn more and use more new skills as they gain more experience or get more training on the job, etc. Our job at the schools is to give them some fundamentals so they can become good problem solvers in whatever field they're in, with the fundamental tools that they have learned, the fundamental technologies and that they've learned in the classroom. So it's a fuzzy picture because we're looking at the whole career pathway as they grow and mature in their jobs, but also trying to define a skill set that we would like to put them out the door with, so that they're good employees and can go to work and adapt to their new environment, their work environment, as quickly as possible with the skill set that we've given them. So that does include that whole gamut of strong technical skills and interpersonal skills, and also those critical thinking, troubleshooting skills, which includes working with big data. So bringing that back in, if they have to, then that's they shouldn't be afraid to tackle that and learn enough about it to do the job that they're in, or the job that they want to have, the next job that they want to have. So we certainly have to make sure that they're prepared for all of that.
Marilyn, can I make a comment about the ET program, please?
Yes, please
Sure,
do, Mike,
sure.
because I would have if you didn't.
Okay, I'm Mike Ennis. Now I'm a business advisor for Florida Makes and the EDC of the Space Coast. I'm also a adjunct professor for Eastern Florida State College ET program. Between 1982 and 2020, I was a manufacturing engineer for McDonnell Douglas, for Boeing, and L3 Harris. And all three of those roles, I was responsible for hiring the technicians that would assemble the space shuttle payloads at McDonnell Douglas and Boeing, and also the technicians that would assemble the deployable reflector assemblies for the satellites made by L3 Harris. When I was looking for technicians, I would have three categories. So I'd have a digital technician, an electrical technician, and a mechanical technician. The mechanical technician, I would expect them to have a varying degree of background in HVAC, pneumatics, or hydraulics. The electrical technician needed to know how to do the soldering, build cables, and install electrical components, and then test those components. The digital technician was more in line. They would run the control rooms, and they needed to know how to solder, and they needed to be strong on troubleshooting skills. So when I look at the engineering technology program, I look at it being a place for people within our communities to get the skills to get these jobs that I just explained. So to me, as when I was a hiring supervisor, I wanted strong basics. I wanted somebody that knew their electrical background or knew their mechanical background or digital background real well. If they had a 2-year degree in either one of those 3 areas, I knew that they were trainable. I knew that they knew the basics well. And when they came on board, I could take them, learn what they were good at, and then take that person into a more detailed role. So I look at the engineering technology program. It should stay strong on basic engineering concepts and stress all the classes, in my opinion, should have a lab. Everything you teach ET student, you need to teach them how to use their hands, because the engineers are going to University of Florida, Georgia Tech, MIT, all these schools. They're learning all the theories, and the people coming out of the ET program need to know how to use their hands to take those theories engineers give them and put them to use. So in a nutshell, that's where I look at the ET program. It should be a good program teaching basics in the engineering technology disciplines. Thank you.
Okay, thanks, Mike. Well, we're just about here at the end. It's a little bit early, but if anyone else has any comments, I feel really bad. We had a number of people got kicked out and couldn't get back in, even though they re-registered and did a bunch of things. So thanks. I guess some of us made it through most of the session here today. So sorry about that. To those of you who have colleagues that got kicked out, the session has been recorded, and we'll get that out to everyone as well. But right now, I'd just like to ask for any more comments. I'm going to ask Danielle if she can put the link to, there's a 3 or 4 question kind of evaluation. Can you put that in the chat for everyone while we take some last comments here? Anyone? Nothing? Everybody's ready to cash it in. So let's see, we've got it here, and I've got it now on this last. Oh no!
All right. So
we
let's.
got to. Please. Go ahead.
There is
Richard.
somebody trying to make a comment, I think. Nope. Okay. So back up one slide just so that they visually. Right, this is where we were when we asked what else, and then the next slide proceeds us towards the finishing thoughts. And those are the next steps that we're going to do. We're certainly going to review these essential skills with a lot of thought with the new ideas that we got today, but regrouping, renaming, a lot of good information there. We've got to review some of the input about the 4 gaps that we identified for you. The skill list, 5 critical cross-cutting skills. We're going to think about those some more, and any more input you have today will be valuable. And then ultimately, we're going to disseminate and implement. And certainly Mike Ennis's comments were very well taken. And the next slide. In order to do this, we have to implement ways of implementing change. There is a lag, fortunately, always a lag, but fortunately in Florida, we've been working with the Department of Education for a long time to minimize dead time. These dead time is really dangerous. And for those of you outside the state, the big player that we have now is there is just one engineering technology degree and it's focused entirely on servicing the manufacturing industry. So all of Mike's comments were made with the insight that he's working in that degree structure. However, I do have to quickly say that Mike's choice of the 3 outstanding engineering colleges in the country was askew. He missed one of the more prominent ones, and I'll let him eventually, the next time he talks, acknowledge that faux pas.
I'm
College
sorry,
credits.
I left out University of South Florida, the great school from the West. My
Well,
apologies.
thanks, Mike.
Oh, Richard, I thought you were going to say Clemson. Okay, never mind.
No,
Sorry.
well, that's true. For those of you who don't appreciate this, remember this is a Florida-based group and a Florida-based ATE project. So some of you coming in from the outside world can have a distorted view of life in the big city.
We're
So
your friendly neighbors.
that's absolutely true. And you're a valuable neighbor and valuable input and always have been for a very, very long time. The idea of college credit is what drives ATE. And so we've always been focused on that. And we do appreciate that that's a mechanism in Florida that we can use. And special topic electives. Ron probably didn't, I don't think he mentioned it, but he was probably using some of those courses that he has in his structure as electives initially so that he could lower the lag and get things going to respond to his industry players. We also have other ways of implementing change. The Florida Makes effort is statewide. It's actually national because they're part of the NIST MEP group, and the Florida manufacturers do respond to their services. Equipment, education equipment suppliers are a big source of change for us here in Florida. And look who just popped in. Mark Gaudio has a comment there. And his company is one good example of the equipment suppliers. And we have several very high level, high effort working folks that that provide opportunities for us to change the curriculum. And OEM training is super important in Florida. That map that we showed you several slides ago, those areas are inundated with OEMs, original equipment manufacturers. And so they provide a good source for how we're going to implement change.
Okay. So we thank everyone for coming and all of the Go Bulls comments in the in the chat, being here on the West Coast. We like the University of South Florida, but right now we really like you to do the evaluation survey in SurveyMonkey. There's a QR code there if you want to do that, if you're on your phone, and the survey link is still in the chat under Daniele's comment, just a little bit up the page. If you're not, everyone do that before you leave. I hope you enjoyed your lunch. Those of us on the team didn't get any lunch, so we're going off to eat individually now.
And some thoughts about how hard the process was, because one time when I was doing this, when I was someplace else, it was challenging for me. So if you have any thoughts about that whole procedure, because we'd like to use this mechanism, but if it's a pain in the neck, we'll find something else.
Yeah, that would be good. You could write that in the evaluation. Actually, there's a comment box that you could use for that, as well as other comments on both the process we used and some of the outcomes. Lots of food for us and some more in our journey to finish up this project, which we'll be closing out this summer, early this summer, with some recommendations for the degree in Florida, and taking those to both the educators and the industry through their advisory committees, as well as through some of the industry organizations, the regional associations, and the Florida Makes Advanced Manufacturing Workforce Leadership Council. So anyway, great to see everyone here today, and have an awesome weekend. And lastly, again, don't forget to do the survey. We will be posting the information, the slides, and also the recording next week sometime. So you can look for that.